Lesson 626, Chapter 6, Section 2, Lesson 6, Cases with Infinite or No Solutions. The daily learning target is, by the end of the period, the students will solve equations that have infinite solutions. Infinite means many, and those with no solutions. I should not have to define the word no. Your in-class will consist of questions Chapter 6, 116 to Chapter 6, 119. Following me going over this information board, we will be going over the in-class. Your homework for tonight will be Chapter 6, questions 122 to Chapter 6, questions 127. The attachments for the in-class and the homework can be found on Jupyter. Thank you. Oh, before I start today's in-class, I hope that you have all found the attachment through Jupyter and have printed yourself a copy so that you can follow along. Okay, let's begin. 626, cases with infinite or no solutions. Many students believe that every equation has only one solution. However, in the introduction to this lesson, you might have noticed that if Annika was 4 years older than her brother William, they could never be the same age. I'm right here. Some situations have one solution, others have no solution, and still others have all numbers as solutions. Let me make that bigger. Is that better? Is it better that it's bigger like that? I think it's better that it's bigger like that. Okay. For each of the following equations, reason with your team to decide if there is one solution, no solutions, or all numbers are solutions. If there is a single number solution, meaning one answer, write it down. If you are not sure how many solutions there are, have each member of your team try a number to see if you can find a value that makes the equation work. So, let's look at A. X equals X. When would that be true? Would that be true for one number? Would that be true for no numbers? Would that be true for any number, all numbers? That's correct. It would be true for all numbers. Because whatever value I put here, it's going to be the same value that I place here, even if that was a decimal or a negative or a fraction. Okay, go down to B. On the left side, you have X plus 1 equaling X. Will that have one answer, no answers, or all numbers? So this side will always be 1 bigger than this side. Will that ever be true? No. No solution. All right. How about this one? This one's a little trickier. This side is X, and this side is twice the value of that. If I told you that there was one number where that worked, could you think of that one number? Shall I give you a little bit of time to think that through? Oh, I hear someone in the back. That is correct. X does equal 0. Because 0 is equal to 2 times 0, which makes that 0 as well. Good job in the back. All right. Look at D. Let's see. This side, if I wanted to simplify it, I could say this is 2 times X. Where this side is going to be 2 plus X. Is there a number that I can multiply by 2 which would result in that number adding 2 to it and them being both equal? What's that in the front? Yes, good job. X equals 2. Okay, you ready to go to E? Let's go to E. So over here on the left-hand side, I am adding. And over here, I am subtracting. So what could, and these x's all have to be the same number. So what would I be adding together on the left side that would equal me subtracting a number from each other on the right side? Some of you are probably thinking, well, if you have x and you subtract x, wouldn't that give you 0? I wonder if I place 0 in place of x. What's 0 plus 0? Oh, that's right. It is 0. So I think our answer is x equals 0. Oh my God, you guys are so smart. Okay. Let's clean up for F, the left-hand side. What's x plus x? No, it is not x squared. It is 2x. And over here, I have 2x. Do I have the same thing on the left as I do on the right? Why, yes, I do. So guess which one this one is? It is all numbers. By the way, the ones for E, C, and D, those are one solution because in the directions it said if it had one solution, you need to put what those are. Okay? All right, what's going on in G? What does that dot mean? It's not a decimal. That's right, it is a multiplication sign. So what is x times x? No, it's not 2x, we're not adding. It is x squared. Do I have the same thing on the left and the right? Correct. But is that my answer following the directions? No. What is the correct answer? All numbers. Okay. So look at H. H kind of reminds me of B. This side is 1 less than x. So the left-hand side will always be 1 less than the right-hand side. Is there a number that would make that true or equal? No solution. Okay. You guys, if you get stuck, try plugging in some numbers. I would try plugging in -1, a 0, or +1. Because those are smaller numbers that are very manageable. You try to negative, you try to a 0, and you try to positive. Try those 3 values out and see if it works for all 3, then it's all numbers. And if it only works for one of them, then that's your one answer. If it doesn't work for any of them, it's probably no solution. All right. Question 117. Use the 5D process to write an equation for the problem below. Then answer the question. So Kelly, she's 6 years older than her twin brothers Bailey and Larry. So how many kids are there when there are twins? There are 2 of them. And I'm going to use K as my variable for Kelly, and she's 6 years younger, so I'm going to put +6 because if I add 6 to Kelly's age, I will get one of her twin brothers. Now, if we distribute the 2, like that, what would we get? What is 2 times K? 2K. What is 2 times 6? That is 12. Do I have the same thing on the left and the right? Yes. So this is true for any age. All right. I'm going to let my pen hold that while I give you a minute to get caught up. And then we're going to go to the back. How are we doing so far? You guys doing good? Okay. That looks a little blurry to me. Is that blurry? Oh my gosh, you guys, that was blurry. Why didn't you say something? Okay. Maybe I should put my glasses on. All right. Oh yeah, that's a lot better. Okay. Okay, we're going to the back. Special cases part 1. Use the equation x 8 plus x plus a -5 equals -4 plus x plus 7 to complete parts A through C. All right. A, build an equation on your equation mat using algebra tiles and simplify it as much as possible. Record your steps and what you see when you have simplified the equation. Draw a picture of your final mat. Okay, so on this mat, what would 8 look like? 8 positives. Okay, those are little squares, but are they shaded or not shaded? Can you remember? I'm going to draw them while you think if they're shaded or not. How many do I need? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, did you decide if they're shaded or not? They are shaded. Let's go back and shade them. Okay, so that took care of the 8. What does the X look like? This is a positive X. Yeah, it's a bar. Draw your bar. But is it shaded or not shaded? Shaded. Okay, and then this negative 5. 5 not shaded squares. Make sure. 1, 2, 3, 4, 5. Okay. So then on the other side of my equal sign, I have a negative 4. I'm going to put these down here because it'll be easier for me when I zero pair them out. Okay. What does the positive X look like? A shaded bar. Whoops, I'm not shading real well there. And then 7 positive. 1, 2, 3, 4, 5, 6, 7. What did I forget? I forgot to shade them. All right. So now simplify it as much as possible. Okay, so what do I have on the left that I also have on the right? Because I can remove those. Oh, that's not called zero pair. What's that called? Balancing. Okay, so what would we balance out? How many of the little shaded squares? 7. I better count them. 1, 2, 3, 4, 5, 6, 7. Circle it. Did you see I changed colors? And grab these guys. Okay, what else does the left side have that the right side has? A shaded square. Take it off that way. Okay. How many of the not shaded squares should I remove from both sides? No, not 5. 4. Okay, so that takes care of balancing. What about zero pairing on the left side? Do you see it? Yep, good job. Right there. Right there. Okay, so my mercy, what's left? What do I have on the left-hand side now? Nothing? What do I have on the right side now? Oops, sorry. What do I have on the left-hand side? Nothing. On the right-hand side, nothing. So you know what? Instead of leaving it blank like that and making me think that you just didn't answer it, we're going to make ourselves a little note up here. Nothing left on the mats. Okay, make yourself that little note because otherwise you're going to go back and look at this and say, oh, I never answered that. Okay. Going on to B. Have each member of your team test a different value for X in the original equation, such as there's our 0, there's our positive, and there's a negative. Although I told you to use -1 because it's smaller, you can use another negative number. I just want you to try numbers that were easier for you to work with. And then there's another big positive. What happens in each case? Well, if there's going to be nothing here and nothing here, the equation, trying to see if I can still see, is true for any value of x. Are there any solutions to this equation? Yeah. If so, how many? Well, if it's true for any value of x, what do we call that when it's all of them? We say there are infinite means many, solutions. Sorry about that short blank. Okay. Hey, we're almost finished. Special cases part 2. Use the equation x plus 2 equals 2x to complete. Oh, so this is just like what we did in 118. So, let's see. What are we going to draw for A? X plus x. That's a bar. How many do I need? 2. What's that you say, Team 1? Oh, shade them. Okay, I'll shade them. Thank you, Team 1. Okay, so what else do I have on the left-hand side? I did this x and this x. What's this? Those are little squares. Okay. What's that, Team 8? Shade them. Alright, that takes care of the left-hand side. On the right-hand side, what's that? I have 2 what? 2 shaded bars. Okay, let's do this. Is that all I have? Yep. Okay, switching pens. Alright, time for balancing. What am I going to balance? What does the left-hand side and the right-hand side also have that I can remove? 2 shaded bars. Goodbye. And goodbye. Alright. Anything else? No? Okay, so what do I have that's left over on the left? These 2 shaded squares. Made one bigger than the other. Okay, sorry, dude. Make you bigger. And then what about on the other side? Nothing left on this side. All right. Have each member of your team test a different value. So then, will this side that has 2 ever... Sorry. Will this side that has 2 ever equal this side that doesn't have anything? Will it ever equal it? No. So, the equation is never true for, can you see? Oh my God, screwed it up. Any value of x. Is there a pattern to the results you get from the equation? Sure there is. The left side is always... How many more? 1, 2. 2 more. That's a 2, by the way. Sorry. 2 more than the right side. Scoot that up. Did you find any values for x that satisfied the equation? No. No. The equation is never, I'm going to capitalize never, true. When there is an imbalance, meaning it's not going to be equal on the left and the right, when there is an imbalance of units left on the mat, such as that 2 over there and the 0 over there, what does that mean? Does that mean there's going to be one answer? Does that mean that there's not going to be any answer? Or does that mean that there's going to be infinite number of answers? That's right. There is no value for x that will make it true. And by true, I mean equal. Is x equals 0 a solution? Well, if x equals 0 was a solution, then it would have a solution. So, no. 0 is not a solution. Okay, so if you need to replay this, if you need to whatever review this, that's fine. But I was supposed to take up 30 minutes and I took up 22. I'm doing pretty darn good. Okay, so I think that concludes this lesson. What's that you say? What do I look like with my glasses on? All right, one little quick peek. And don't make any four eyes jokes. Ready? I just have to turn this around. Oh no, I could do this. Wait, how do we do this? Okay, I don't know how to do it. I don't know how to turn it around, kids. I'll just turn my phone around. Hi guys, I miss you. Okay, I'm concluding the video. So now with the rest of your half hour, not the rest of your half hour, with the rest of your half hour, and then with the half hour following this, you can go ahead and start your homework. Again, the attachments are in Jupyter. Okay, bye for now, kids.